Good. Thank you very much, and thank you everyone for being here. Um, as David was saying, this is going to be hopefully a very interactive presentation. So I'm using Mentimeter. I don't know if you're familiar with it, but if you can get to that menti.com and enter the code, or use that QR code on your devices that you might be doing in your on your mobile or on your laptop. Usually, a lot of people use it on their device, on their mobile. But if you use either one of those ways to get to the presentation, you will be able to see the presentation, although I'm sharing it in Zoom, but you can also interact with it through your mobile, your iPad, or your desktop. So I'm gonna give them just a minute or so to give you the chance to do that. When the link is still at the top of the screen, and so you can see it at the top of the screen where it says like, menti.com and the code. While we are all joining, I will start with a question. And I guess that many of us use estimation techniques, whatever they are. And I'm wondering is, how well does your current estimation technique work for you? Three options. One is like, it doesn't really work. The other one is like, kind of works. And the last one is, it's awesome. It's really working for us. So we're not asking what is your estimation technique, but just like, how well does it work for you today? We got 18 people already that have provided their answers. Let's see if we get one or two more. Just for a minute, and then we'll go. There we go, one more, and then we're 20, and then we can move on. But you're looking at that feedback at the moment, it's kind of like the majority of us is kind of work. Quarter of us is like, it doesn't really work. And the other one, about 16% of us is, yeah, it's awesome, it's working. So, and that actually is really more or less the kind of feedback that I get when we start this presentation. Is usually in the 70, 80s, even 90% of people that say it's not awesome yet. It's kind of like somewhere. Okay. So what this starts to say is like, whatever estimation technique we use, probably there is some room for improvement. So I'd like to explore what David was saying before, is why it's important to estimate. Why do we need to do estimation? Yeah. And perhaps explore ways in which we can probably do better estimation, or see how well the current estimation actually is doing for us. So I'm not here to say this estimation is good, this estimation is bad. I don't know your context, so it would be wrong for anybody to say this is right or wrong. I'm just going to talk about why some of the estimation techniques, or why we estimate, and share some of my own experiences of using different estimation techniques. Now, with that feedback that we have on the screen, what I would like to then to say is to explore is, what estimation techniques do you use? Yeah, so it's gonna offer 6 options there. You can choose more than one. And the options are story points, t-shirt sizes, flow metrics, functional points or function points, no estimates, and person days. So as you start responding, what you will see is that it's going to do a little bit of like mapping to whether you said it works, it didn't work, it was awesome, or you didn't answer. See how those things map. At the moment, a lot of people are using story points and t-shirt sizing. Clearly ahead, clearly popular. Let's see a few more and see how we end up. And typically, story points and t-shirt sizes are very, very popular. It is interesting that sometimes culturally, or like business culture, or even national cultures, you make a different pockets. I was recently doing this talk in a conference in Israel, and there, for example, the vast majority of people were using person days. So in the Israeli Agile community, the most popular one, or at least for the audience that I had, was person days. Hey, that's fine. That's what they use. But in this case, in this group, we seem to be using story points and t-shirt sizings quite a lot, which is it's the sort of thing that I would expect normally. They are very popular techniques. So that's why the talk has the title. It has the title. They use the story points in there. Are your story points? All your story points belong to us. If you get the connection to like you get to where it comes, the title is you get extra brownie geeky points. Yeah. The why I use this title is because there is this picture from many years ago. Tom and I were just talking about, we couldn't remember the name of the game. The game was called Zero Wing, back in the late 90s, late 80s, early 90s. Very popular game in Japan. When it got translated to the US market or the English market, it was a really popular game, but it was riddled with translation mistakes or misinterpretations of the language. Yeah. So what this bad boss meant to say is, we have defeated you. We conquer all your bases. But the way they translated it was, all your base are belong to us. Yeah, we conquer you, really. And what I'm trying to use like with the talk is that sometimes when we talk about estimation, the thing that we have is that sometimes we have forgotten the intent, and we are potentially misinterpreting what estimation is meant to do. So we have sometimes, I believe that we have sometimes forgotten why we do estimation. So I would like to revisit that. I'd like to talk about that a little bit, explore that, and then see how we can use why all those estimation techniques that we use are there, or what they're there for. So I'll talk about the why. So let's start with what's the purpose of estimating work? This is a question for you. I'm gonna give you a little bit more time because you can type, but I like to have your definitions of what's the purpose of estimating work. Why do we do this? Why do we bother? Especially if 80% of us say that it doesn't really work that well or it's a little bit of a meh. Yeah. So we're doing all this effort, we're doing all this estimation. Why? What's the purpose? Let's see what we come up with. Give you a few seconds. Create more certainty in sprint outcomes. Okay, good. Like that. To understand the effort required to complete an issue. What effort there? To plan work better, absolutely. To know when will be done. I got a whole book that says when will it be done? Dan Bacanti, a great book about metrics. What else? Understand misunderstandings. Okay, so that's the conversation thing aspect of it. Understand effort, time, complexities of work required and how to deliver and planning. Good. For the sake of it, that's good and honest. I like that. Predictability. I think predictability is something that's really important in business. Yeah. But how do we do predictability? And that's one of the reasons why, for me, flow metrics are so important. It can help us to have more predictability, or understand how work works. What else? Understand relative value of effort, more predictability, sizing PBIs, make predictions, establish. Okay, lots of good stuff. I love all those things. My favorite so far as well is for the sake of it. Okay, it shouldn't be just for the sake of it. So let's explore why we do estimation. Now, before we go into this, the thing is that actually, when we are doing estimation, there are two kinds of estimation. There is estimation for single items. So if someone tells me, I've got a story, I've got a PBI, can we estimate these individual piece of work? And then we have what we call multiple item estimation. So it's like, I've got a sprint backlog, I've got a backlog, I have a bunch of work or project, whatever it is, that needs to be estimated. And I need to do it for multiple of them. Okay. And the estimation technique, or what we do, how we estimate these two things, are different. They're related, but estimating one item It's not the same as estimating a whole bunch of items. Yeah. We need to do the one item estimation really well to be able to do that well enough. Yeah. But they are not exactly the same, and we shouldn't go about doing the same thing. So let's explore single item estimation first. And I would argue that the sole purpose of estimating work, single item work, is to answer two questions. Question number one is, can we do this work in the time allocated to it? If you're doing a Scrum, can we do this work within the sprint length? If you might be given a deadline, you might have Kanban cadence that you say, we are trying to, we have an SLE of particular number of days or whatever it is. Yeah. So if we have time allocated to it, can we do it within that time? Okay. And the second question is, do we understand this work well enough, not perfectly, just well enough to get going, to start with it? That's all we try to do with estimation. When people say, "Oh, let's not do estimation until you're in the conversation," that they're referring to that second part of a question. That second question is, the conversation is about do we understand it well enough? We know that we're not going to know everything, but do we understand it well enough? But the first one is, can we do it? Can we do it quickly enough? Can we do it within whatever is the tolerance levels of our environment? Maybe because, as I said, you have a sprint, you have a deadline, you have service level expectations. Does it fit? Is it of the right size? So if you think that there are these two questions, then there are really only three possible answers. There are four, but one of them is not really, doesn't matter. Yeah, but there are only really three possible answers. The first one, which is the positive one, is when you can say yes to both questions. Yes, it's small enough to be done in the time allocated to it. And yes, we understand it well enough to start working on it. If you can answer, if a team feels that it can answer yes to those two questions, go for it. It's small enough and we understand it enough. Let's go. Fair enough? Now, the other two questions is when we answer no to one of the questions. So if the answer is no, it's too large to be done in the time allocated for it, then we have to break it down. It's too big. Doesn't fit. It's not of the right size. So we just have to make it a little bit smaller. Usually we will decompose it, we will break it down, whatever we do. Yeah. If you're familiar with those famous lunar logic planning poker cards, yeah, you can see that it's too big. You know the F in the middle, what it means. All right. So that's when you answer no to the size question. It's too big. Break it down. The other one option, the final option, the third option is when we say no, we don't understand it well enough. Yeah. If we don't understand it, then we have to refine it further. We have to explore it further. We have to have more conversations. The lunar logic cat is basically implies no clue. Yeah. So 3 options. We either understand it, we understand it is small enough, go for it. Too big, break it down, or we don't understand it well enough, refine it further. Those are the only 3 options. And if the whole estimation, to me, the whole of the estimation process we do, and we start thinking about whether we should be working on things, it's basically about answering those questions. Yeah. So when we sometimes go and we have many more questions, things like planning poker, it can actually be potentially unnecessary. It can actually be too much, looking for too much precision. It can be helpful to say, well, occasionally you might say, yeah, is it a 2 or 3 or 5 or an 8? it becomes my experience sometimes it becomes inconsistent. People don't keep a baseline of what a 5 means or an 8 means, and we lose the point of saying, is it just small enough to do it during the next X amount of time that we have for it until we basically, or maybe until we plan again or whatever it is. Yeah. So sometimes adding more than adding all these options is just potentially unnecessary. Okay. So so we see sometimes that we put so much sometimes effort in helping teams or coach teams to do planning poker and planning things and the story points like that. And to me, it's kind of like we go very much into the mechanics of a planning poker and the mechanics of this relative estimation, and to the point that we potentially even forget why we were doing these things.
I have a question.
Yes.
So if you are in an estimation session and 3 people say this is a 1-point story, and then somebody says, well, I think it's an 8-point story. I guess there's some value in knowing that there's quite a difference of opinion, and then you can have a conversation and say, well, why do you think it's an 8? And it might be that the rest of the team have missed something. I guess that's the only thing I can think of.
And that's for me is answering the question. When you're asking the question, is it small enough? Yeah. If people say whether it's 1 or 8, sometimes people say it's 1 or 1.8, and we forget to have a conversation. It's like, okay, 1 or 8, but is it small enough to be doing it in the next period of time, in the time allowed to it? We forget the other part. Yeah. Whether if you have 1s and 8, you have difference of opinion. Have a conversation, absolutely, because what it means is probably we have a different understanding, or we have a different experience. So that is illustrating that there are the two parts of the question. The 1 and 8 sometimes is like we have different understanding about what needs to be done. So it's into the refine, yeah. But if you're talking about 1s or 8s or 5, is don't forget it's about like, do we believe that it can be done? Yeah. And that's what sometimes we forget. We got too much into the weeds of the mechanics of a story point in a planning poker. And I've seen that done occasionally, quite mechanically. There is a reason why planning poker was there, is for these things. It's just to maybe unearth a little bit of a difference of understanding. Yeah. But we forgot that, hey, the question is like, does it fit? Can it be done in the time? Do we understand it well enough? So sometimes we forget that.
Could I just ask a follow-on question to that, Jose?
Yeah, of course, of course.
So I'm just kind of picturing a like a planning session, for example. So we might be doing refinement, and the question is, will it fit into a 2-week sprint? And
yes.
the answer might be yes, it'll fit. But you
yes.
might have 40 things that would fit individually in a 2-week sprint.
Yeah.
But when we come to do planning, collectively, all those things that we've said yes to may not fit. And one of the beauties I find of pointing in Fibonacci or some other way is we could say, last sprint we did this many, this number of points, and therefore we think we can bring this many stories in. How would you do that if everything's just a 1?
I'll get into that.
Okay, fine.
Yeah. And one thing is about the individual story has the story point allocated to it. That's single point estimation. Yeah. When you are saying for the sprint I have 40 points, then you are going into multiple item estimation. So I'll get into that in a minute. Yes.
Cool. Okay. Yep.
Yeah. Because you're now trying to say whether the batch of work can it be done.
Got you.
Okay.
I thought when you said multiple items, I thought you said multiple you're going to estimate them all at the same time, but you're not necessarily saying that.
No, it's multiple.
Yeah, I'll let you get onto it. I'm jumping the gun.
It's a great question, actually, very, very pertinent. So good, thank you, Tom. All right. So where I'm going with this then is that, so we got all these 3. So this is unnecessary, and forgive me if it sounds a little bit controversial sometimes. Story points had a really good point. Story points have a good point. The story points had a good intent. Yeah, sometimes what what I've seen is they have become these kind of like mechanistic, theatrical things that it try to give us the answers to those questions, but it's not really addressing these two questions well enough. Yeah, so we become many times mechanistic and we forget the purpose of why we're trying to do estimation. So that's one of my thoughts, and I'm happy to say that potentially is controversial, but I feel that that's something what I see. A bit of cargo cult in there. So we said that we got good intent with these things, but some things that have good intent end up being what we say can be used or abused. Yeah, and now I'm offering here 6 different things, and I would like you to think whether you think it's a binary choices, whether each one of those things is a good use or is it abuse of the whole idea of estimation and story pointing. So we have things like Jira story points with decimal numbers. Is that good use or abuse? Things like normalize story points across multiple teams. We see that. Is that good use or abuse? Ever increasing velocity. You know, a typical manager that say, give me more velocity. Is that a good thing or is it an abuse of the intent? So you see where I'm going, yeah? We have the billing on story points deliver, use the story points to access a team's performance, and the last one is reduce ticket size to increase the velocity. When people say, give me more velocity, hey, I reduce the ticket size and deliver more tickets, then increase velocity. So 2 people have chosen. I think those 2 people have decided that everything is an abuse. Let's see what the rest of you think. Hopefully I'm not leading the witness. If you end up with, okay, there you are. We haven't got consensus anymore. Excellent. Let's wait a few more. Okay. So if as a group, this is the data we're getting is we are erring towards thinking that it feels probably more that these are misuse of or a bit of abuse of the intent. Some disparity on opinions, that's absolutely fine. I would say that most of the things, all these things, to me, they feel more like an abuse of what the intent was. But yes, I mean, it may be true that it works in some environments, fair enough, yeah. But to me, when I've seen these things being used, there is always an underlying cause. It's like, doesn't smell right. Doesn't smell right. So anyway, thank you for that. I think we got like good numbers there. Now I'm gonna ask you a question, another question, and I would like you to see what you will answer. Now, this is a statement, and you have to tell me whether you think it's true or false. And the statement is, story points must correlate to time, and I'm making the must in uppercase. True or false? Okay. Very, very, very clear opinion there. What do you think Jose thinks? Shall I show you what I think is the right answer?
Come then.
Oh, it's not sure. Yeah. I actually think that statement is true. Remember the first question I have, like, I mean, assuming that I'm right in that the 2 basic questions that we should ask about estimation. The first question is, does it fit in the time allocated to it? The first question is all about time. The second question is all about knowledge. Do we understand it well enough? But the first question is and was about time. The whole idea of estimation is always going to be, it has to translate to something in the real world. Yeah, one of the key things in the real world, and it's about time. We talk about
Jose.
effort. Effort is about time. Yeah.
Jose, Imran, yeah.
Hmm.
Uh, I mean, I won't call it controversial, but point to think. Uh, why do we use story point then if it's going to relate to time? Just use time, some unit of time.
Very good question. And I'm gonna when we talk about flow metrics, we're gonna use time. Okay.
Hmm.
I would say we could use time, but we can use time in a different way. What I'm not gonna argue for is don't do don't do actually let me tell you why. I'll do it now. There is kind of like a really really important thing that I think we forget or we have forgotten when we try to. If I gave you this, I'm answering the question. Yeah, it's gonna take a
Yeah.
little bit of a detour. When we say estimate this piece of work, imagine that
Mm,
it's full of words and everything. Yeah, it has writing in there. Yeah,
mm.
imagine that we're estimating it. What are we doing? How do we estimate this piece of work?
Well, normally it would be the size. I mean, if we are doing story points, then
Yeah,
normally it would be the size of work. Yeah.
yeah,
The what and the complexity.
yeah. So, but what we're trying to do is to actively estimate this piece of work. So
Yeah.
we will analyze it, we'll make sure if we understand it, we will
Mm,
start thinking about, all right, how much development will it need, in which area of our code base,
mm,
this is a
mm,
difficult area of the code base, or if we touch that API, oh God, that requires all this extra testing. And don't touch this other part because that's it's free, it's really, really brittle and it breaks every time we touch it. Whatever. We started actively trying to estimate what needs to be done to this thing.
mm,
Fair enough. And there is actually a fallacy here. There is a real fallacy. If it, this work, whatever it is, this is going to be, we
mm,
have never, ever done it before.
mm,
We have done something different, something similar perhaps. So that's why we feel we can estimate it. But
mm,
this specific piece of work is the first time we're going to do it. So it requires a creative step.
mm,
You cannot estimate how long a creative step is going to take us. You can't possibly because you have never ever done it. So at best what you can do is judge your experience of doing similar things, yeah, and act and then say, well, I've done these things similar before. It took me 20 days. So probably it might take me 20 days. Yeah.
mm,
But trying to actively estimate this is a creative step. You cannot really estimate the creation, the creativity moment. You can use your experience to extrapolate. That's what we talk about relative estimation.
mm,
Yeah. So what we will do with flow metrics is to say, don't try to estimate this, use a statistical forecasting.
mhm.
We put a lot of business theater in trying to estimate this when we don't understand it well enough because we haven't done it. The only time when I know how much effort this will take us is when
When we actually do it.
we have done it already.
Yeah.
Then you know how long it will take. Yeah. So there is a little bit of a fallacy that we try to actively estimate something that requires a creative step.
Does this raise the effort versus, because there's often an effort versus complexity debate, isn't there, where effort is purely time and complexity, throws in dependencies and risk and other things, including effort, into the mix as well.
And I will say that our systems are going to be complex. So you're going to have the complex of the work, you have complex of the environment, of the different environmental factors that you have. So you have a lot of complexity that is even more difficult to actively estimate. Yeah. How do you estimate the lack of coordination? Or how do you estimate the coordination problem? How do you estimate the sequencing of work challenge? Yeah, we actually, when we estimate, all we are estimating most of the time is like, I'm going to do this, I'm going to do that, I'm going to do that, I'm going to do that. All right. If we got it right, good. But when we don't estimate is, I'm going to do that and then wait for 3 weeks because someone is on holidays. And I'm going to do that and then wait for another 2 weeks because I have a dependency on a third party third-party supplier who just changed the API and it cost me to do that. Yeah, you don't estimate the delays, you don't estimate the inefficiencies in our process. No one does. And that's why many times when we actively estimate the work that we need to do, we get it grossly wrong. We get it wrong many times. It's because we cannot even estimate that complexity, that unknowable things in some ways are not easy to estimate. When I mention forecasting will typically have captured these things. Is that okay? So
yeah, perfect.
that was a controversial statement. I'm trying to do this, but the thing is, like, whatever estimation we do, it has to. I mean, there is a bit of like, I use the word must to create a little bit of a reaction. Yeah, you could say should correlate or should have enough correlation to time to be useful. Yeah, if your estimation technique, whatever it is, does not correlate to time, the estimation technique is not working. Yeah, and I'll explain what do I mean by this. You do recognize, yeah.
So I did put it in the chat as well, and I'm not disagreeing with anything you're saying. I mean, the reality is, no matter how you bake it, your velocity equals time because you're in a sprint. So it's related to time regardless.
Yes.
But for me, it's not actually about the question of the points. The points are a vehicle to achieve something else.
Yeah.
It's actually about the relative sizing, you know, and it just happens to kind of be defined as points. Yeah.
It could be t-shirt sizes,
Exactly.
whatever technique you use, must have some correlation to time, must show some correlation. Is that okay, Dylan? Yeah. So in this case, story points, you recognize like the sort of like semi-Fibonacci sequence that we use. Good. Now, if I put in there instead on the horizontal axis, I put like some sort of a lapse time, real time. Yeah. What we will have is that if you have perfect correlation, yeah, every time that you go to a different story point, it should translate to a specific time, elapsed time, if there was perfect correlation. Yeah. So in this case, what I'm using as a rule is that every story point doubles up the time. Yeah, but that's a choice that I've done so that it fits in the screen. Okay, it could be other multipliers and things like that. But if every 8-pointer will be perfect correlation, you will have like 16 days, for example. Yeah, and that's because I'm using a 2-to-1 ratio in this case. Yeah, but you will have like perfect matching. That's not going to happen. There is going to be a margin of error. Okay, so what you will probably see is that the 5 pointers or the 8 pointers will group around a range of dates. Yeah. Typically, it will be the margin of error below towards the lower end is going to be shorter. We usually, when we make the estimation wrong, it goes into because things have happened and it makes us much worse. So you will see that the range kind of like is not exactly balanced. You know, it's more to the right, to the higher end, but you will still see some sort of correlation where there is a bit of overlap, but you can see the differences. Yeah, that if you were to plot your story points to the actual time, yeah, and you saw something like this, I will say your use of story points or your use of whatever you're using will work. It's working well enough. Okay. Now, when people have done these kind of things, and I know people like Larry Maccherone, Mattia Battistone, Larry Maccherone in the UK, in the US, Mattia Battistone and Chris Young in the UK, and so on. I've got people that have shared with me data for like something like 6 or 7,000 data points. And when you look at this thing, it often looks like this. Larry Maccherone did tens of thousands, hundreds of thousands of data points. All right, it looks like that. where the story, there is no distinguishable ranges. Yeah, the story point, you see the yellow bars. Yeah, the overlap between, you know, a 1 pointer sometimes can take as long or much longer than a 20 pointer. Yeah, so the overlap is almost indistinguishable. If you end up with something like that, what you're saying is like your story points has a random correlation to, it has no correlation, it's almost random and stochastic data. Yeah, if that's the case, if that's what you have, your estimation technique, whatever it is not working. Yeah, if your estimation technique is trying to say these are different categorizations or different sizes of the work, does not correlate to elapsed time, that technique is not working for you. Yeah, so my advice is check it. I'm not saying that it's right, the story points are wrong or right. They can be absolutely right. Yeah, but do you check it? Yeah, so my question for you as a group, sorry, I need to go one back, is do you check that your estimates correlate to elapsed time? So three answers possible. Yes, and they more or less correlate. Yes, and they show no correlation. And no, we don't check. Hey, thank you for that. So if you don't check, please do. I advise you to do it, because you might be using a technique. Hey, it might be working for you and we just don't know. Yeah. So I advise you to check. Yeah. If you are checking and it don't show any correlation, it's like, how can you improve it? Because we're putting all this effort in estimating. So how can you improve it? Whatever technique you're using. And if it's working for you, awesome, keep going. Yeah. So good one. Thank you very much. Now, we've been talking about story points, t-shirt sizes, and all those things. I tend to believe that, in my experience, like cycle time, which is one of the key flow metrics, offers a better, more reliable approach to the single time estimation. So I say, like, forget the story points if they don't work for you. If they don't work, use cycle time. What's the power of cycle time? When cycle time is calculated when I complete a piece of work. So I finish a piece of work and I measure the cycle time. Now, that measurement, that elapsed time, has incorporated all the things that we needed to do and all the inefficiencies and waste and, you know, rubbish that we many times have in our working practices, all the errors and things like that. And by taking many cycle times as we finish work, and many is not that many, it's just a few tens, yeah. What I will have is data that tells me how our work works. The good, the bad, and the ugly. And so when you are going to estimate the next one, which, remember, I said you cannot really estimate this actively, what I could say is, does this compare, is this the same type of work of what we've done before? The big pieces, the bad pieces, the one with blockers, the one with dependencies, whatever happened. Yeah, this is normalized data now. It's comparable data, provided that this is similar enough. Yeah, so I could say, all right, I don't need to estimate this. I can run flow metrics on this, calculate the cycle time, and use this to estimate this. It's a 10-second job. Because what I'm saying is that this work compares to what I've done before. So if I know how long it took me to do this cycle time, I can use that to forecast this. We remove, people say, but what about the conversations? Please have the conversations to make sure that this is comparable to this. Please make sure that this is understood well enough to be able to do it. Yeah. So the conversation is important, but you don't need to do potentially some of this business theater that we see in trying to estimate things which are not really estimatable. Is that okay? So flow metrics give you, like, typically, for me, and actually I will say, don't go and throw the baby with the bathwater. If you're not really sure about if you're using story points, keep using story points. compare them to the correlation to real time, and then try to run cycle time in parallel, which is very cheap to do, yeah, and see which one of the two might give you a better reliability. So keep doing the story points, compare to cycle time, see which one might be giving you a more reliable estimation process.
Hi,
Krishna?
Jose. Can I ask a question here? Sorry.
Yeah. Yes.
Just my key question is the reason why I joined this session is mainly because we're kind of using time to estimate our stories, and we're using like a technique like where if a fully qualified developer, tester, everything, they can deliver they'll have we assign them an 8 points. That means like a 2 weeks sprint where 2 days goes for training and rest of it, and 8 is actual capability they have to deliver it. And that's how we're using that to relate to the user story. It's kind of directly relating to the time. And a lot of times when I go to different places, it's always they say, oh, why you're not using, why you're not talking about complexity and all of the stuff, which we tried a lot of times, but we ended up in relating the way you're talking to me. Is it something right method approach you think we're currently using works?
Yeah, just remember that what I was saying in the beginning. I don't know the context, so I wouldn't be able
Yeah.
to say. But what I will say, whatever technique you're using, yeah, see how well it translates. If you say that it's an 8, yeah, see whether like whatever you're doing to do different estimations, yeah, does it correlate to time?
Yeah, that's same. 8 points is related to a sprint, which means 8 days per fully qualified. If the person joins the new, you'll have a 0 points because he can't deliver anything because he's new. His velocity will pick up. After first sprint, his velocity goes up to the 20%, so he can only deliver 2 points in the sprint, like that. And we are correlating the story points, including it's purely time. Like a story point is like 3 points means it's 3 days to deliver. Directly relating to that. If it is 8 points means too complex, we'll get it down to at least five points so that they can finish it in a week, and then someone can test it on deliver on the same sprint itself.
Okay, I don't understand the whole process entirely, yeah, obviously.
Yeah.
But what I'm hearing is that you're doing some sort of like point allocation based on the person.
A person and the time. It's like the person means. Sorry, I think I'm trying to complicate it more. We are allocating 1 point means 1 day.
Yeah. What I would say, whatever technique you have, I cannot judge whether it's going to be or wrong. I will not have enough time to understand it, yeah, in a session like this. But what I will say is that if you think that it's going to be whatever, you're end up allocating 5 points or 8 points or 3 points, however you establish that, yeah. If at the other end when you deliver it, the 5 pointers look. They are grouped around a particular range of time, and the 8 pointers have a distinctive difference, and the 3 pointers are distinctive. So if you get a distinct correlation to elapsed time, keep going.
Velocity is matching with exactly what the point. Like not exactly every time. There will be some blockers, some other external factors which we can't factor in, but it's linking because we're linking to the time. But a lot of times when I go to different places, a lot of people talk about complexity, a lot of other stuff they're talking about. That makes me confused a bit, saying it is working for me. Why should I change? So
if it's working for you, I mean, we can have a chat later because obviously it's too contextual, but if it's working for you, what I'm saying from the beginning, if it's working for you, keep going. Yeah. If you're curious, run a parallel test and see whether it's more reliable, less reliable, or whether it's less effort, because sometimes it's like how much effort it takes to do the estimation. Is that okay, Krishna?
Yeah, sorry, thank you. Yeah.
Oh, no, great. Thank you for that. And then, so this is cycle time is the key metric that we use for single item estimation. When we go into multiple item estimation, which is the next one, I think that for this one, the purpose of multiple item estimation is to answer 2 questions again, but they are different questions. And the questions are the questions that business will typically ask us. Yeah. Let's see if anybody guesses the first one.
When will it be done?
When will it be done? Exactly. That's one of the 2 questions. The first question is the other one, which is how much work can we do by a certain date? That's the typical thing that we do in sprint planning. how much work can we actually do in the next X amount of days that we have for the sprint? Or we are doing a roadmap planning. How much work can we do in the next quarter? Yeah, that's the question. Yeah. The other question is, how long will it take to complete a batch of work? We got 10 pieces of work, or we got a backlog of 250 million items. How long will it take you to do that? Yeah, those are the two questions that we're doing when we're doing batch estimation, multiple item estimation. Yeah, so to answer those questions, I would like to check what you as a group, or what techniques do we use? You can do multiple answers here. The options are velocity using story points, then velocity using the count or the number of stories done, burn-up charts, cumulative flow diagrams, Monte Carlo simulation of throughput, and Gantt charts. Let's see what we come as a group.
So, Jose, while we're waiting for the scores to come in, there was a question in the chat from Richard. How much cycle time data is needed to give reliable estimates? It seems like its accuracy will be higher the more data you have.
More data can give you more precision, definitely. It's more important that you have relevant data or recent data than quantity of data. So it's one thing that is kind of like a bit difficult to believe, but statistically it's true. Yeah, we only need to have 11 data points to be able to do statistical forecasting confidently. So if you're trying to do cycle time estimations, yeah, you only need to have the data of 11 stories, and that's enough to do a statistical forecasting. Of course, if you do 20 or 100 or 1,000, you're just getting more confidence in your data, yeah. But you are already in the 90% confidence range to just with 11 data points. And actually, having more data is not always the right thing, because some of the old data will be so old that is not representative of the current system. For example, if you change staff, team members change, or you have gone, things have changed, you have been doing continuous improvement, you have done retrospectives, how you work today could be really different than 6 months ago. Yeah, the data from 6 months ago, it's no longer representative, so don't use it. I keep telling teams, like, use the previous, whatever is the context, but use the previous month, 2 months, 3 months, when the data is still representative, when it still feels that whatever happened at that time is similar enough to what we're doing today, the way we work, our experience, the team composition, stuff like that. So sometimes more data is actually not better.
Thank you.
Yeah, thank you. That's a great question, Richard. All right, okay, so what we have here, we have velocity with story points is very popular. We have velocity with the number of stories done, popular as well, Burnett charts, and then less of like CFDs, Monte Carlo simulation of throughput, and Gantt charts. Okay, so let's have a look at this quickly a little bit, but velocity is quite popular. When we talk about this multiple item estimation, typically what we are doing is use what we call a count over a period of time calculation. I'm going to give you some examples. Yeah, story points per sprint, what we call velocity, yeah, is multiple item estimation. Is a number of story points, that's a count over a period of time, the sprint. Yeah, someone is using the number of PVIs finished per sprint, is also velocity calculation. It's also multiple item estimation. Yeah, using the number of work items done per day, what we call throughput, is also multiple item estimation. Yeah, they have the same pattern. Is some sort of count, story points, count, or the second two are count of tickets or items, and a period of time. The sprint is a period of time. the day obviously is a period of time, a unit of time. So all those are multiple item estimations. Okay. Now, when we use the story points per sprint, how do we calculate the velocity? What does the velocity is the story per sprint of the previous sprint, or is it of a number of sprints in the past? Do you use just the previous sprint data? We got 25 points done in the last one. We use the 25 points this time, or what do we do?
It's an average of the last few or something like that.
Yeah. So we tend to take an average. Yeah. Don't use averages in complex work. It's dangerous. There are sharks in there. Okay. Why is one of the things is like, okay, as an example, why averages are dangerous. Yeah. If my friend Bill Gates walked into this session right now, yeah, my friend, we will, on average, everyone here will be a billionaire. Yeah. If Bill leaves by Bill, yeah, everybody's back to be skinned. Yeah. The problem with averages is that they're very, very sensitive to outliers. That's one thing. Yeah. And also when we are using averages it tends to be towards the median point, the average. Yeah. It's very close to the median. And the median means, yeah, the average and the median are not always in the same place, but they're going to be similar places in this complex work. It means that you have 50% chance of getting it right, 50% chance of getting it wrong. That's what we get with a median. Yeah. So by using averages, it means that we are only we're using a measure which is only has about half a chance of getting it right. That's usually too risky.
Jose,
yeah.
will it not depend on really what's the variance in your velocity? If it's consistently stable, I think average should be fine. But if it's like there is a lot of variance, then no, definitely average is a problem.
I will say again, if your system is, I'm not saying that velocity is wrong. I say like there might be dragons. If it works for you, it's like absolutely fine to use the story points and velocity. Typically, what we said, story points have, if they have no correlation, that's a problem. And I said one thing is like, in order to do multiple item estimation, we need to do single item estimation well. Yeah. So if your story point is working well and it has good correlation, then you probably can use velocity quite well. Be careful about the fact that we are estimating at that middle point. A middle point says that you have half a chance to get it right, half a chance to get it wrong. Yeah. Your system is very stable. Okay, excellent. Keep using the story points or whatever you use. Keep going velocity, however you're using it. But if these things are not working for you, I'm trying to say why they might not work for you. Yeah. The thing about averages and typically the averages and velocity, one is they are based on a metric that potentially is not reliable enough. If it doesn't have correlate, the story point or the t-shirt size, whatever it is, might not be correlating to time. And then you are compounding this, or we compound this, because I've used velocity many times before. We compound this with using an average, which is a 50% chance of getting it right. It's a coin toss of getting it right. So no wonder that many times we get it wrong, because we literally are aiming for the 50 percentile. Yeah. In business, typically what we need to do is to go further up. I mean, my calculation of velocity will not be done at the 50th percentile. I'll try to do it at the 85th percentile. That gives me much more confidence. Yeah. And that's why
there is a thanks for this. There is a question in the chat. When we talk about velocity, are we talking about speed or speed and direction, which is what velocity is, speed and direction?
Who has the question?
It's in the chat.
I would like to invite the person to come in.
Yeah, Michael.
Michael.
Sure. Hi.
Yeah.
Okay. So My understanding of velocity is that it is a combination of speed and direction. It's not just speed. So if we're talking about velocity in this instance, are we talking about just speed?
Yeah.
Or are we talking about speed and direction?
So how do you see the, I'm curious, how do you see the direction part?
Well, that's kind of what I'm asking here, because that's really the definition. And when you're talking about velocity, the definition of velocity is speed and direction. It's not just speed.
Okay.
So that's kind of why I'm curious. And I may be being pernickety, I agree, but it's it's curious.
Yeah. That, to me, direction is more connected to, for example, if you're using a Scrum, yeah, the team will have a sprint goal.
Sure.
And the sprint goal provides the direction.
Okay.
And it provides the reference where the team can continually assess if they are, are we about to meet the things.
Yeah.
But velocity is more connected to me about the speed, about the capacity of the team.
Okay.
Yeah. The
But
direction is more connected to a goal.
Yeah, but then in your calculation, you should refer back to that, to the sprint goal, in order to ensure that the direction is maintained, or the direction is represented in your calculation.
Yes. Okay. I think the two things are absolutely relevant, but they are not entirely the same. So
Yeah.
teams need teams without any goal, teams without any direction. They're doing work for the sake of doing work. Yeah, and potentially they just, why are we doing the work? It's very difficult for teams to inspect and adapt using the Scrum language if they don't know what they need to deliver or why they are doing things. So the goal is kind of like necessary regardless of whatever estimation technique you're using in this case, because things will happen. So the team needs to say, okay, how do we, what decisions do we need to do to achieve what we need to achieve? It's I don't know if the word orthogonal here is it's the right one, but it's the two things are actually trying to assess two things: is how much work can we actually do? That's the velocity estimation conversation. And then are we going in, are we, with that amount of capacity, are we running in the right direction? That's more towards, I think it's more connected to work goals. Yeah. If we're using the same language to use the same words, by the way, because we might have a different definition of what we mean by direction in this case.
Sure.
Can I invite Avni? I think you have the hands up a couple of times. Avni?
Yes, hi. This is Prema. Hey, Premalata. Avni is my daughter's name. Sorry, I'm using her account.
Okay.
Yeah. Michael, you are right. Velocity and speed are different, but they are about scalar and vector quantities. They don't relate in this context.
Yeah.
The direction in like mentioned is a very qualitative term. It is it's the direction as in sprint goal is a qualitative term. Not sure how that can be used, how we can relate that in scalar and vector terms. The definition, the literal definition of speed and velocities, they are scalar and vector quantities, whereas the direction we say here is different. So I think they are not relatable here.
Thank you for that. Yeah. I mean, for me, is that they're both useful. I mean, one is about capacity. The velocity is about capacity, how much we can do, or how long will it take us, and the direction is more about like the goals. What are we trying to achieve? Yeah, and those are important, but they're not exactly the same. So yeah, thank you for that as well. Okay, so if I'm saying that the velocities, again, if it works, that's absolutely fine. But if you are experiencing that your velocity is maybe a little bit of a hit and miss, or it could be better, you want to make it more reliable or to correlate better to actual capacity and so on. What we tend to use in flow metrics is use throughput. Okay, So we can say like bye-bye to velocity, hello Monte Carlo. It sounds luxurious. But what we do with Monte Carlo simulations is a statistical forecasting technique, okay? We use throughput, and throughput is the amount of work done per unit of time, like number of items per day. Remember, it was one of the examples that we gave, yeah? And what that we can do is like run many simulations of what might happen in the future. And you build on a statistical model where we say, okay, we know that for a typical sprint, we tend to do 15 stories or more, perhaps, and with a certain amount of confidence. But 80% of the times we deliver at least 15 stories. So when you go into planning session, the team then can go and say, okay, which might be, if we want to do 85% confidence, yeah, if we want to have a lot, like we don't want to have too much risk of missing that planning, yeah, or missing the capacity, the team can go and have a conversation with product owner, the teams, if you are using product owners, to say, all right, what might be the most important 15 items that we could select? Yeah. You have to be careful that, potentially how big they might be, but, this statistical calculation has used all the things that have happened in the past to predict what might be happening in the future. It may be that your average is that you deliver 20 items per sprint or 25 items per sprint. Yeah. But if you want to be really sure that you can deliver, pick 15. The data is telling you that 15 is much more safe. Yeah. What happens if you run out of work in the middle of a sprint? Pick more work. Scrum, if you're using Scrum, that's not forbidden. Yeah, you can plan as many times as you need in the middle of a sprint. Scrum only says that you have to do a planning session on the first thing that you do at the beginning of a sprint, but it doesn't say that you cannot pick more work in the middle of a sprint. Yeah, so you want to do good capacity planning. If you want to achieve predictability, remember one of the people said, what is the purpose of estimation? Someone mentioned predictability. If what you want to have is that kind of predictability, that kind of planning, it's relatively straightforward. You run Monte Carlo simulation on your data. It tells you that potentially you need to pick 15 items or more, but you want to be safe, pick 15. Now the difficult part, going to the direction part, is which 15 might make more sense, which 15 might deliver more value. Yeah, that's a different talk. Because you could pick really bad 15 items, yeah, but that's a different kind of talk. That's other kind of magic, yeah. But at least you know that the capacity of the team is pick 15 or more. You are going to normally do 15 or more, okay, but that might be where you start, okay. It depends on how ambitious, how much risk you want to take, how many you pick. Question?
Jose, Imran, yeah, again.
Yeah.
I'm just thinking out loud. I mean, for me, throughput will work best. I'm saying best when you will have similar sized items. Yeah.
No, not necessarily. No, doesn't
So,
mean.
for instance, if your one item is big and another is very small,
Yeah.
Does it average out or?
It's a myth. Typically our systems have so many variables and have so much variability and so many things affecting it, like you mentioned, complexities and things like that. Size matters, but it's actually for many systems is not the most important determining factor that tells you how long it will take to do things. So the fact that everything has to be the same size, it's actually a fallacy in complex work. Complex work is inherently variable, and size is variable. Yeah, if not, everything will be exactly the same size. We are not in that world. That's the world of manufacturing and things like that to some degree. Yeah, our world. What is important is the work is of the right size, not same size. Is right size. Remember when I started with the beginning with the single item estimation, one of the two questions was, is it small enough to fit in the time allocated to it? that's a right sizing question. Is it small enough to fit? It doesn't say is it the same size? Is it 3 days? It could be 1, 2, 3. When it will finish with different size, different length, and what determines how long it takes to do, it's going to be the effort, the dependencies, the holidays, sickness, all other things that you cannot really control to some degree. They're inherently variable. Yeah. So even trying to do same sizing at the entry point does not deliver the same size at the exit point. So don't waste time in trying to make the same size. Just make sure that it appears to be of the right size, small enough.
Great, thanks. There
Yeah.
is a question in the chat by Dylan. Why is estimation so important to business, whereas value often is not questioned?
Oh, that's a fabulous question as well. Estimation is important because we there are many questions, many answers, and probably will take too long. Let me try to answer very quickly. We seek certainty, we seek predictability. Okay, and it's important. Actually, come on, Sleepy Fox. I know you are going to have a great question, a great answer.
The answer to that question really is that most businesses don't really account for value, they account for cost.
Yes, that's
and if you ask stakeholders, how valuable is this? You have some really interesting conversations, but most projects don't actually start with a good business case with good estimations of value delivered. I think over 30 years, I've encountered perhaps 2 or 3 companies that actually not only estimate value delivered, but actually measure value delivered and do a round trip and compare estimations to actuals on value delivered per unit time per developer. It's incredibly rare.
If I do a yes and, because it's yes, yeah, and we're talking about estimation, and we're saying that actively estimating something, creative step, you don't really know it. So we are a little bit of like, if we try to actively estimate it, is finger in the air, let's find out. Yeah, estimating value, it's even more of a finger in the air. You only really know the value of something delivered when it has been delivered, when you have customers that actually love that feature. So again, we put a lot of business theatrics in. Let's calculate value. Let's estimate and prioritize based on value. And it's like, but you don't know the value. You really cannot really know the value until it's been delivered. Value is a lagging indicator, which is what Nigel Sleepy Fox is saying. It was saying it's like, you may have an idea what the value is. You think you have a guesstimate of what the value is. Okay, do you correlate it back after it's been delivered? Do you check that you have a correlation, that your valuation techniques actually translate to the real world? Most companies are too scared to run that correlation. Yeah, because it's kind of like poof, smoke. Is that all right? But that's a different conversation. That's a different talk. Thank you for that. It's a great question. So just, I know that we're doing the question, so this is overrunning. Yeah. Let me just do a Steve Jobs, moment. One more thing. Okay. There is another metric that probably most people have never heard of. There is a chart called the aging work in progress chart. Okay. What aging work in progress chart is doing is that you are comparing, you are assessing work that is currently in progress against the work that has been done before, which is comparable work. Yeah, that's cycle time. Yeah, and you are saying, is it moving well? Is it progressing faster, about okay, about this right pace, or is it moving slowly? Yeah. So when you can compare that, it gives you the opportunity to totally transform how the teams have conversations. We will talk about this thing about self-organization, self-management, and this is all woolly. Yeah. Really, really powerful technique for teams to self-organize, to say, this is what we are doing right now. How well are we progressing? And it allows people to anticipate delivery problems before it's too late. Yeah. So it's like voodoo. It's the best kept secret in Agile. Yeah. What you will have with a chart like that on the screen, yeah, is those, you see all those dots that are on the screen. You have all these areas with different colors, and you see some dots. The dots is the actual work. How long has it been in the system? It's representing how long it has been in the system. Where is it in our process? If it's on the green area, typically it will mean that it's going fast enough. Yeah. Now, depending on how you set it up, the red is usually mean it's going too slowly. Orange usually means danger. Yellow, be careful. Yeah. But what you will have as a team is look at that in the daily stand-up, daily scrum, whatever you're doing. Look at like, how is the current work that we have not finished yet? We are working on it. How well is it progressing? Oh, something is on the red zone. Let's talk about it. Let's see what can we do to resolve that problem before the problem becomes too late. Teams that are using the aging work in progress, it's like they're doing voodoo. They go to Hogwarts and they do magic. This is defense against the dark arts. Okay. When I've seen it used, when I see teams using it, it can be really, really powerful. And the vast majority of people have not heard about things like this. So I will encourage you to do it. When you do that, when you potentially, as I say, if it's working what you're doing today, keep going. Maybe I will say you're curious, compare to these metrics that I'm talking about. But if you want to try it and you get them and it helps you to do better metrics, then what we potentially can do is really level up and defeat that estimation boss that we had at the beginning. So thank you very much. All the things that we're talking about is very much inspired by books like Dan Vacanti on metrics, and the sort of work that we do with metrics and how to use metrics for predictability. That's it. That's me. I think we have a lot of questions, but I can take more questions and we can have a chat. Thanks.
Thank you, Jose.
Thank you so much, Jose. Thank you. That was awesome. And I'm sure there'll be more questions. I know I've got one or two, but I don't want to be greedy, so I'll let other people get in first. Well, they're taking too long, so I've
got one as well, David. You go first, though, because I've already had mine.
Yeah, I was itching to say, ask about the. It was really interesting, the slide about the flow metrics and Monte Carlo, and and the one before that we were talking about don't use averages.
Yes.
And I was really interested because I was thinking this feels counterintuitive. There's something about using averages and the law of big numbers, and it makes me think, oh, it will be okay because we're averaging out. And then when we talked about the Monte Carlo and we talked about, if you can be confident that you can do 15 items per sprint, and those items they're all right size. Some of them might be smallish, some might be a bit bigger, but they're all roughly right sized.
Yeah.
You're kind of averaging there, aren't you? You're not.
Yeah, but what I will be doing is that 15 items that I'm saying, I am not taking the medium. I will be taking something that gives me more business confidence. So I will be making that prediction, that forecast on probably the 85th or 95th percentile. Yeah. So this graph here, it's going to be too small. Apologies for this. This one is about when will it be done. So what it's trying to do is to predict dates. in the future when
Okay.
100 items will be done. Yeah. But what we're saying is like, don't go for the average. Don't go to that middle point there. Yeah. I will go and pick the 85th of 95th percentile. Is how much risk your environment can tolerate for late delivery. And if the answer is not much, don't use averages, because averages is 50% likelihood of getting it wrong, like 50% of getting it right. So I need to become more conservative, yeah, and say, okay, well, if you want to have 85% confidence on that I can hit the delivery date, then you have to give me more time. Yeah, this is doing the, you start with a number, then you end up with a date. The other option is you got a date, 2-week sprint. What is the number? Yeah. And for that, you're doing the same metrics, but it's slightly reversed. It's like, all right, so I could typically, my average, my median is going to be, say, 25 items, but that has half a chance of getting it wrong. Maybe I only get 24, but that's wrong. Yeah. So if I want to that becomes the over promise under deliver, when you start to say, what do we cut in the scope and things like that, which we talk so much in Agile. I would rather go and say, no, realistically, with more confidence and with less risk, the data tells me that I should take only 15, because that's 85% confidence. We're going to deliver at least 15 or more. So, hey, why don't we pick 15? That is confident enough that we're going to hit that most of the time. If we can deliver more, awesome, we'll pick more work and deliver that. So I'd rather under promise and over deliver. The use of averages is too close to me to the over promise and under deliver.
Yeah. So average, I can see that's a good answer. So if you were going to carry on these story points, you might advise people to err on the side of caution. And if you've got a range between 25 and 40 points, maybe nearer to 25 than to 40. Yeah.
But I would, if your environment does not accept, if there is a little bit does not accept that risk, err with caution. Yeah. Now we do this actually naturally. When you ask people for estimates, what do? They add a little bit of buffering and padding. Yeah. But that's, again, protective. Yeah. What you can do by using statistical analysis, and there are tools that do all this for you. I don't know statistics well enough to do this. The tools do it for me. Yeah. But what this is telling me is that, okay, you need a trade-off. You want more confidence. Well, this is how much time you have to allow. Yeah. And you continuously reforecast, because then you can continuously say, yeah, well, with what we learned from last week, this is the forecast now. And it could be better or worse than it was, but we just learned we have very recent data the last week. And by using that data, this is how the forecasting is changing. That's what hurricane prediction does all the time. Yeah, as the hurricane keeps moving, they keep reforecasting where the hurricane may be. Yeah, why are we not using the same techniques?
That's a really good answer. Thank you very much.
Thank you. And Dan Baganti has a talk that talks about something like your project behaves like a hurricane. So why are you not using the same techniques?
Good. You've got a question.
Yeah, I think I've answered my own question in my head, but I'll ask it anyway. Just see what you think. So,
yeah.
One thing it feels like you haven't put much emphasis onto is breaking work down, because normally you hear about people saying, we need to break work down as atomically as possible.
Yeah.
But you haven't really been pushing that point. And one thing I was thinking was, the question you posed at the start is, will the work item fit within the time?
Yeah.
So let's say that all of the items that we ask people to estimate, let's say they're all huge, they're all 2 weeks, they're all 2 weeks worth of work.
More than 2 weeks, yeah.
They're massive pieces of work because they haven't been broken down.
Yeah.
So we might have like 10 pieces of work that all technically fit within that period of time. We can't pull all those in, so we because we don't actually know how big they are because they're just one point things. So I think the way of answering my question is, once you do this Monte Carlo analysis, you'd realise that you can only get one piece of work done in a sprint, and that would force you to break this down. Is that the answer?
Yes, and no. Yes. I mean, if all the candidates are that big, yeah. What probably what you had is that at single item estimation, we missed the question: is it small enough to fit? And I'll explain why. Can I draw?
Yeah. It
Okay.
could do though. Let's say a week and a half then. Let's say, just for argument's sake, a week and a half. They're all a week and a half massive things.
Let me quickly get God, where is the whiteboard? Why is it not show?
While you're finding the whiteboard, I just have to mention that, like back in the 90s, if you said a week and a half was a massive piece of work, people would have laughed at you, because a massive piece of work was like 6 to 12 months or more. A week and a half was nothing.
Yeah. But in today's world, that's almost a sprint, isn't it? So you couldn't do two of those things. You can only do one.
All right, I'm trying to get the whiteboard, but it's not showing me the whiteboard. So this is quite annoying right now. Let me. I have.
It either needs to be enabled by the host, because you can turn it off. So it might be turned off.
The host. Okay, well, let me just show a blank screen, and then I can share the screen differently. So give me a sec. I can do this quickly, and then I'll show you what I was trying to going for. All right, so that's a blank screen, yeah.
Yep.
So what I will do, and hopefully this works, is that God, how can I do this? All right, imagine that this is if this is time.
No, we can't see anything.
No. Just give me a sec. If that's time, yeah. And what you will have is you will have when you finish all the work. Sorry, when you finish work is gonna finish with different length of time. One will be finished in 1 day, other ones will finish in 2 days, 3 days, 5 days, 25 days. Yeah. As you start capturing that, this is cycle time down here in that axis. Yeah. That cycle time distribution will follow a path like this. Okay. So you have items which are very small, items that are very small, or maybe 1, items that are very large, which are maybe 25 days. Yeah, this is what we're talking about. Like the items will not be of the same size. There is a variability. Yeah, and this is the most common size, which is going to be, let's say, to be like, let's say that this is 5 days. Okay. Now, if you're using a 2-week sprint, what potentially you could argue is that the 2-week sprint, it's there. So that's 14 days. Okay. Right sizing, and the question about estimation is that when you're pulling the work, you don't know how long is it actually going to take you, because you don't know what things will happen. Yeah. But does it fit comfortably in the time allocated to it? Yeah. And for me, comfortably is perhaps 85% of the items that we work will be done within the sprint. Or if I want to be much more precise, I could go and say, all right, I really want, because I start to have a very old commitment mindset of Scrum. Like the vast majority of items that we start will need to be done in the sprint. Yeah. Does that make sense? So the majority of items with whatever variability have to be done in actually, well, it's elapsed time. So yeah, 14 days. Yeah. Weekends count in metrics. Yeah. Is that okay?
Yeah, makes sense.
This distribution that you have, that red distribution, means that the work that you bring in has to feel really small enough to fit in whatever is your sprint. In this case, we're using the 14-day sprint. Yeah. That's why many times people say, oh, you know why we say stories should be done in 2 to 5 days and no more. It's this, is that this is right sizing. This is the concept of right sizing. You want the stories to be, most of them done in that kind of bracket, the 2 to 5 days, let's say 2 to 6 or 7 days, so that when the ones that get a little bit bigger for whatever reason, because they get blocked, because something happens, they can still be done within 14 days. And then there is other things to consider, like parallel work, and you may have multiple stories working, blah, blah, blah. Yeah. But right sizing needs to say, yeah, the sprint is 14 days, but please don't size everything at 14 days. Make it much smaller so that when things happen, you can still deliver it within the time allocated.
So you
That
would still put some emphasis on size then. You would, when you're asking people to estimate.
With that?
So you're saying that when you ask people to estimate, you would put a level of emphasis on that.
I would, so
on 2 to 5 days.
Well, what we typically will do is that the right size is try to make every individual item, say that I'm doing random numbers here, yeah, but say like the stories have to be done in just a few days, 2 to 5 days, no more, because when things happen and time potentially elongates, some of them will be done in 1 day, but some of them will take a little bit longer. Some of them will be that kind of monster of 25 days. Yeah. So when things happen, you are still most of the time within the sprint.
Yeah.
And there is a few caveats that I'm making a few assumptions. Like you are not going to start all the work at the same time. Not everything starts at the beginning of a sprint. Some things just start maybe 3 days before the end of a sprint. Well, if you start 3 days before the sprint and you sized it to 14 days, you got no chance of finishing it in the sprint, which for a Scrum is actually absolutely fine. You don't have to finish it, provided that you don't compromise your increment. Yeah. So, but that's the concept of right sizing. It's like it has to be small enough to feel comfortably, and and that's where the decomposition comes. And there is another thing. I mean, you're all familiar with this famous acronym, INVEST.
Yep.
The INVEST has actually a real contradiction in there. There are two of the terms. Are you familiar with INVEST?
Yep.
Work is independent, negotiable, valuable, estimatable, small enough, and testable. That's what we say is a good story. Yeah. But in there, two of those elements are directly at odds with each other. Which ones? The valuable and small enough. They are directly opposite. The smaller it is, the less value it packs. But if you want to deliver value, then usually you have to deliver more pack. More that is a bigger piece of work. So what do customers want, or what do stakeholder want? All they want to talk is about value. What do developers want? Small enough to remove uncertainty and so that I can get feedback loops.
Yeah, I've always interpreted the valuable bit though as something that someone can like see, they can use, they can give you feedback on. So
Yeah.
for example, creating a database table wouldn't be valuable because
No,
but I'd say it's not valuable. It might be small, but it might not be. It's not valuable.
but the more what I'm saying is that the more you decompose the work to smaller, the decomposition challenge is that the more it's decomposed, it can be decomposed to the point that it carries no value.
Yeah.
Yeah, and that's and who is in the middle of that tug of war? The product owner.
Yeah.
And this is the real product owners. If anybody is a product owner, you can wear a cape and wear your pants outside. It's like a superhero because you have to balance this real challenge of like people want to deliver value. You're talking about value, yeah. But also we need small feedback loops, small work to get the feedback loops, yeah. And finding that optimal balance point super difficult. Yeah, and sometimes you see stories that because we have, again, I'm going into a lot of things, because we have artificially created a 14-day, 2-week sprint because everybody does 2 weeks, suddenly you have stories that for the context are just too small and don't carry any value. Yeah, so you see all these things, and sometimes it's just like when I talk about the use of misuse or abuse of. Sometimes we see things that people are forgetting why we should be doing these things, or what's the value of these things. Hopefully this is not too much of a tangent. By the way, it's almost like a different talk.
This is really good, and Jose, it's clear that you're incredibly passionate about this, and it feels like you could go on and talk all night about it, but I want to be respectful of your time, so maybe we should draw the questions towards a close. Has anybody got a final question?
And it's more a statement, if I may, David. You know, story points, estimating, relative sizing, forecasting, all of these are just tools and data points, right? I think it's when people either misuse or misunderstand their purpose that they, you know, they're not as valuable as they could be. You know, for example, estimations are often used in a team as just to encourage that conversation. You know, is there a discrepancy in our understanding? But I never use that for forecasting, because I know the, you know, as humans, we're fallible to, you know, a bunch of things. So I think, yeah, it's just, I mean, it's a great talk, Jose. I like having that that comparison between the two, you know, and for the purpose of understanding, you know, not to saying one's right, one's wrong, but just understanding. So yeah, that's all I wanted to say. Thanks very much.
Yeah, and just to be clear, I'm not saying that the one is right, the other one is wrong. I'm saying please compare and make sure that, you know, it's working for people. Yeah. I do have a preference, that's obvious. Yeah. But there is no one is better than the other ones. If it's working for you, whatever you're doing today, even if people are using cucumber based estimation, I don't care. If it works, it works. Yeah. For you, that's okay.
Jose, I have one last question.
Yes.
And this is something that's been on my mind for a while. So if we are using story points, and then you could, I don't know whether it's abuse of it, but you could certainly start doing some forward estimation of bigger things like epics and say, well, we've got this big thing here. We don't really know what it is, but let's call it 100 points, and we can obviously you probably wouldn't like that idea. But if you were to say, right, we'll break it down later. We know roughly what it is, but we'll give it a big number, and then you can use that to forecast. Maybe that forecast is useless, I don't know. But when you're doing Monte Carlo analysis and you're breaking things down, and it kind of is dependent on you getting those things right sized. So if you wanted to look ahead, so I guess my question probably comes down to how far ahead can you look with Monte Carlo analysis in a practical kind of way, in a realistic way? You know, is a year way too far?
Yeah, great question. This is an area where you know, the even in this, where we're talking so far, but this is going to be more. A sign of complexity is that people don't agree, or even the experts don't agree. Okay, and I'm not calling myself an expert, but you know, where there is divergence of opinions as well. I use a lot of, like, when I'm trying to take agility beyond the teams, and we start entering things like organizational agility, multi-team agility, product management, portfolio management, and so on. I tend to use thinking models like flight levels, okay, and bringing Kanban and all those things as well to those. The kind of things that we are doing on team level with story points, velocity, or cycle time, or throughput, you can extrapolate it, and you, like the metrics that I'm talking about, you can use them at product level, portfolio level, and so on. You just have to be very careful. You just have to be conscious that if there is uncertainty and variability at the team level, when you have decomposed things and it's much smaller, yeah, there is even more variability at those higher levels. But at those higher levels, what you are flowing through is features or epics or initiatives and things like that, you can do the same metrics. Yeah, it's just that you know what? When I was drawing this histogram, that histogram would be far wider because there is so much more uncertainty. Yeah, you can use the same things. You can use the same things to try to use forecasting at that level. It's just that is more uncertain. But we use that. We use things like that well enough to have a more or less predictive environment.
Okay.
Yeah. So my answer is that you can run the same metrics at that at a higher level, like feature level, epic level, whatever you're using. Yeah. And use that and use statistical forecasting on those.
Okay.
Just be mindful that there is even more uncertainty. People like Dan Vacanti, if you watch the Drunk Agile YouTube channel, yeah, there is at least 1 or 2 videos where Dan Vacanti and Pratik Singh talk about how do they do their forecasting at that level. The way they do it is that they try to predict how many stories they will end up having and then use story level predictions. I don't entirely, that doesn't entirely work for me, but I mean, they know what they're talking about, so it's worth having a watch of those videos.
So
empirically for me, it's not working that much to me.
So they'll
Yeah.
say this feature feels like a 20-story feature. Okay,
So
I understand. Yeah.
Then you're using the 20 story, yeah. The problem with me that is like the way that then they go and do the selection, and you watch the video, is that they never change that 20 story became a 27 story feature. It continues to be a 20 story feature, and that to me, that's what I disagree with them. Is like, hey, you know, the story size is the number of stories that will decompose will change. Yeah. When I'm just using metrics of a feature level, the fact that stories that we thought were going to small become bigger and all those things, well, you know, again, the data gets normalized and I can use forecasting to it. I just have a different way of doing it.
It's a really good answer. That's given me something to think about. And yeah, so for people who don't know, Jose he's in Finland, 2 hours ahead. So it's now it's nearly 10:15, nearly bedtime. So I'm gonna draw it to a close there. Just remains for me to say some thank yous. Thanks to the rest of the team who helped organise these events. Massive thank you to Jose. Such a good topic. Obviously, loads of good questions. The most probably interactive session we've had for a long time. Thank you for your time and sharing your passion. And finally, thanks to everyone for coming. I hope you all got lots of good value from it. We're going to end the session there. If people want to hang back for a chat, then by all means, but don't feel you have to. Thank you everyone for coming.
I will share the link to this presentation in a minute in chat if you want to have it.
Great, thank you very much.
Thanks a lot for all the questions. It makes my, you know, if I was just here presenting, it would be a bit boring. So thank you for all the great questions and conversation. I really enjoyed that. Thank you.
And thank you to David for doing such a great job hosting as well. So well done, David.
Yes.
Great topic, really good. It's a pleasure.
Thanks, David.
Thanks, Jose.
Thank you very much.
Fantastic talk. And thanks for making
Jose.
it interactive and interesting.
Thanks, Jose.
Thank you, Jose.
Awesome.